The diagram shows the velocity time graph of an athlete running in a straight line on a horizontal track in a 100-meter race. He starts from rest and has a constant acceleration until he reaches a speed of 15 meters per second when t is equal to capital T. He maintains this constant speed until he decelerates at a constant rate of 1.75 meters per second for the final 4 seconds of the race. He completes the race in 10 seconds. Calculate capital T. The athlete races against a robot which has a displacement from the starting line of 3t squared minus 0.2t cubed meters at time t after the start of the race. Show that the speed of the robot is 15 meters per second when t is 5. Find the value of t for which the decelerations of the robot and the athlete are equal. Verify that the athlete and the robot each reach the finish line simultaneously. Okay, so I've drawn the picture at the bottom here and summarized the question. First of all, calculate t. Well, we know that this is the velocity time graph, so the area under the curve corresponds to the distance traveled. So here, the 100 meters then will be the total area under the curve. Half base times the height, which is 15 for the triangle, plus base, 6 minus t, times the height, 15, plus the area here. Now we don't know this spot here, do we? We know that it's decelerating from 15 for 4 seconds. So 4 of these will be the speed that it gets down to, won't it? So 4 times, this is minus 7 over 4 as a fraction, equals minus 7. So this height here will be 3, is the velocity here. And this is 15, the height is 15. So the heights are 15 and 3, so it's half times the heights added, 15 plus 3, times the distance across, which is 4. Okay, 15 plus 3 is the heights. As we said, 4 of these, because it's 4 seconds, 4 7/4 are minus 7. That's the decrease in speed from 15 down to minus 7. Oh, it's 8. 8, isn't it? Okay, so for 15 minus 7 is 8. So for some reason I wrote down 3, which is hard to believe. So it's an 8. So that's good. So 100 then equals 15t over 2 plus 90 minus 15t plus the 4. What's the 4? Oh, the 4. And this will cancel to leave 2 on top. 15 and 8 is 23, times 2 is 46. So this and this is minus 15t over 2. Take it over there to be 15t over 2 is equal to 136. Take away 100 when you move it over is 36. So t is equal to 2 36s is 72 over 15. 3's 24 over 5. 24 over 5 is 4 5s are 20. And 4/5 is 0.8. Type it in the calculator if you need to. 4.8 seconds is the value of capital T. S robot is 3t squared minus 0.t cubed. S robot, the displacement of the robot, is equal to 3t squared minus 0.2t cubed. Just double check that. Yep. Show that the speed of the robot is this when t is 5, is 15 when t is 5. So the velocity of the robot, if we just differentiate, 6t minus 3 of these is 0.6 t squared. Put 5 in, 6 5ths minus 0.6 times 5 squared. 30 minus, this is 3/5 as a fraction, and 5 squared is 25. 5 goes into 25 5 times. 30 minus 15 is 15 meters per second. So that's the velocity of the robot, then is 15 seconds. which is what we wanted to show. Find the value of t for which the decelerations are equal. So the deceleration of the runner is minus 1.75. So the acceleration of the robot then is equal to differentiate this 6 minus 2 of these, 1.2, 1.2 t is equal to the minus 1.75 is minus 7 quarters. So that tells us then, move the 1.2t over to the other side. And then on the other side, 6 quarters is 24 over 4, plus 7 more is 31 over 4. So that tells us what the time is. Well, we can use this, have this as a decimal actually, because it doesn't do no difference. So it's 1.75 plus 7.75. So 7.75 then over 1.2. 1.2 decimal 6.45, 6.46. And that's the three significant figures. So there's the time where the decelerations are the same. Okay, so did I do that correctly? Yeah, the acceleration of the robot was minus 1.7, minus 7 over 4, that's right. So that's that done. Verify that the race is drawn. So this is part 4. So part 4 then. For the runner at t equals 10, we're told that s is equal to 100 meters. As far as the robot is concerned, s of the robot then is equal to 3 times 10 squared minus 0.2 times 10 cubed. 10 squared is 100, so that's 300. This is 1,000. 0.2 times 1,000 is 200. 300 minus 200 is 100 meters. So yes, the race is drawn. Because they're both at 100 meter distance at time t equals 10 seconds.